Hello students, welcome back to business statistics class. So in previous classes we had studied standard normal distribution and normal distribution, what is normal variate, standard normal variate and its properties. So today we'll start with problems. So before we start with problems, I want you to understand how to find area under the standard normal curve. So this will be used throughout this chapter now. So this is a normal distribution table to find out area. So this area works under standard normal curve. So we know this is the normal curve and this is area from 0 to z. Now you want to find this portion. So take for example this z is equal to say 3. Then here you have z. So under the z check for value 3. So it is just 3, that is 3.0. So for 3 under 0 the value is 0.4987. So that is your value. Suppose you want area from say 0 to here z is, you can say it is 1.9. So what you have to do, under z check for 1.9 under 0. So it is 0.4713. Suppose you want z as 1.94, then what you have to do, under 1.9 and here under 4. So the value is 0.4738. Suppose it was 1.55, then 1.5 under 5. So this is how you read this table. So I hope this point is clear. And one more point to remember is, if you want z as say -3, then again you don't have separate table to find out area from 0 to -z. Because this normal curve is symmetric, that is both the sides will be equal, the area covered will also be equal. So what you have to do, you have to check for 3 itself. So this area will be again 0.4987. So this concept will be understood better when we solve problems. So suppose this is a normal curve. Please assume it is not exactly bell shaped, and this is the midpoint will be your 0, and we know the range is from -infinity to +infinity. So and the area under this whole curve is 1. So when you divide the curve into two equal half, then this will be 50% of the area, this will be 50% of area. So we know area under the curve is 1. When you divide 1 by 2, then it is 0.5. So area from 0 to -infinity is 0.5 and area from 0 to +infinity is 0.5. So remember this, it is useful point. So now say suppose you, and the right hand side takes the positive values and the left hand side takes negative values. So this will be 1, 2, 3, so on up to infinity. This will be -1, -2, -3, -4, so on to infinity. Now say suppose you want to find this region area, that is say 0 to 2. So what you have to do, in the table you have to check for z value as 2. Suppose if you want to find area of, so this is not there now. Suppose if you want to find area of -2, that is this area. So this area is same as this area. So what you have to do, again you have to find out in the table for the value 2. And now suppose you want to find out say area from 3 to infinity or greater than 3. We don't know, because x lies between -infinity to +infinity in normal distribution. Suppose you want to find area which is from 3 to infinity, you want this whole area, then what you have to do is, we know this whole area is 0.5. Yes, that is 0 to infinity area is 0.5. Then from the table we can find out this area, that is 0 to 3. So if you subtract this area from the table which you get from 0.5, so this region is gone, you have subtracted. So you will be remaining with this area. This is what exactly we need. So in the table we can find 0 to 3. So from 0.5, if you subtract 0 to 3, then you will get the required answer. So suppose for the same, if you want to find area say from -4 to infinity, then it is same as area from 4 to infinity. Then what you have to do, from 0.5 you have to subtract the value which you get from 0 to 4 from the table, because the table shows area from 0 to infinity. It is not from z to infinity. So that is the reason we are subtracting from 0.5. And suppose if you want to find the area from, say, this is 0, this is 3, and this is -1. So you want this whole area. So what you will do, from the table calculate, get the area from 0 to 3. For that, if you add this area, then this is the required answer. So for that you have to find area from 0 to 1 from the table, and then add it from the area from 0 to 3, you will get the answer. So with this small explanation, we'll solve one problem, which is a general problem. So the problem is, x is a normal variate with mean 42 and standard deviation 4. Find the probability that a value taken by x is less than 50, greater than 50, less than 40, greater than 40, between 43 and 46, and between 40 and 44, and between 37 and 41. So there are 6 sub questions. We'll solve either 3 or 4 in today's class. So here they have mentioned x is a normal variate clearly with mean mu as 42 and parameter standard deviation is denoted as sigma. So that value is given, which is 4. So here they have not mentioned what is this x. It can be anything, height, weight of a student, or some width of a leaf, so on. So where such problems are used, suppose you want to select few cadets for NCC and there is a restriction, the height should be say less than 160 centimeters, or the weight should not exceed 80 kgs. So in such cases we will be using normal distributions. I mean, it can be used. So say there are set of 100 students. First we can calculate mean weight of those 100 students. Standard deviation can be calculated, which we have studied in the 3rd semester. When you get mean and standard deviation, then we can find out what will be the probability that there are students, probability of students whose weight is less than 50 or which is greater than 40. So all this information can be found out using this normal distribution. So we will see how. So first, x is normal variate with parameters mu and sigma, it is given. To find out this, we have to convert a given normal variate to a standard normal variate. We know standard normal variate is denoted by z. To get z, what you have to do, for x you have to subtract with mean and divide it by standard deviation. That is what is done over here. So substitute the values of mu and sigma. Therefore z is a standard normal variate. So we will see the first sub question, which is probability of x takes the values less than 50. So this x takes less than 50 means it can be 49, 40.5 or 30, 22, 1, minus, so on up to minus infinity, because the range of x is minus infinity to plus infinity. Now here we are interested to find probability of x less than 50. So we will convert this normal variate to standard normal variate. Therefore this equal to p into x minus 42 by 4 less than, so both the sides we are subtracting by mean and dividing by standard deviation. So this will be, so this whole term is nothing but equal to z, we have seen here. So it will be probability of z less than 2. Why less than 2? It is because 50 minus 42 is 8. So 8 by 4 is 2. So we have arrived till here. So once you get this, the next step is to draw a normal curve. So make sure these edges don't touch the line. So now you want to find out area probability of z less than 2. So it means the value can take place from 2 to minus infinity. So this whole region is area less than 2. So how we can find out? We know this area is 0.5. We had just seen the half area is completed, shaded. That is, area from 0 to minus infinity is 0.5 plus area from 0 to 2. So this gives us area from minus infinity to 2. So this is written as area from minus infinity to 0 plus area from 0 to 2. So area from minus infinity to 0 is 0.5 and area from 0 to 2, what you have to do for z under 2, what is the value? It is 0.4772. So we got area from 0 to 2, which is 0.4772 from the table. If you add, we will get 0.9772, which is area from minus infinity to 2, or a probability of z less than 2. So I hope this is clear. This is very simple concept. What you have to do, first you have to convert x to standard normal variate, that is z, and it is done by subtracting by mean and dividing by standard deviation. Once you get that, the next step is to draw the curve. From the curve, you can easily understand how to find out the area. So next sub question is to find probability of x is greater than 50. So here these inequalities play an important role, that is greater than or less than. So don't avoid that. And this inequalities come because it is a continuous distribution. In other distributions like binomial and Poisson, nowhere we had seen this symbols. It was always equal to. So now we want to find probability of x is greater than 50. What you have to do, first convert it to standard normal variate by subtracting by mean and dividing by standard deviation. So this whole term is z. Therefore we will write probability of z. So there is a greater sign symbol, we will write greater than, and 50 minus 42 is again 8, 8 by 4 is 2. So we got probability of z greater than 2. So we will draw a curve. Now we want greater than 2. So it can take 3, 4, 5 up to infinity. So now you have to find out area from 2 to infinity. So how can you do that? We know area from 0 to infinity. So in that, if you subtract this area, then we will get the remaining area, which is 2 to infinity. So area from 2 to infinity can be written as area from 0 to infinity minus area from 0 to 2. So area from 0 to infinity is 0.5, we know that, and area from 0 to 2 is also known, which is 0.4772. So area will be 0.0228, or probability of x greater than 50 equal to 0.0228. So the third sub question was probability of x less than 40. So again the same step. So here this is z. So probability of z, and 40 minus 42 is minus 2. So minus 2 divided by 4 is minus 0.5. So we got probability of z less than minus 0.5. So less than minus 0.5 means area from minus infinity to minus 0.5. So whatever area you want, you have to shade. So this minus infinity to minus 0.5 area is nothing but area from plus 0.5 to infinity, because it is symmetric. If you find out this area, then it is same as this area. So that property is used. So now we will find area from 0.5 to infinity. So again the same concept. First we know area from 0 to infinity is 0.5. In that, if you subtract area from 0 to 0.5, then you will get the area from 0.5 to infinity. So area from 0 to 0.5 is, so under z check for 0.5, which is 0.1915. So they have got the value of area from 0 to 0.5. So when you subtract from 0.5, you will get it as 0.3085. So this is the probability of x taking the values less than 40. So the next one is probability of x greater than 40. So the first step remains the same, convert it to standard normal variate. So it will be probability of z. This time it is greater than minus 0.5. So it can take values from minus 0.5 to infinity. Therefore you have to find out area from minus 5 to infinity. So this is how the diagram looks. So you want this whole shaded region area. So how to find out? We know area from 0 to infinity is 0.5. Then we have to find out area from 0 to minus 0.5, which is nothing but area from 0 to 0.5. So this is written as area from minus 0.5 to 0, that is this area, plus area from 0 to infinity. So now area from minus 0.5 to 0 is nothing but area from 0 to 0.5 because of symmetric distribution. Then area from 0 to infinity. So area from 0 to 0.5 we had seen it is 0.1915 plus 0.5 because it is area from 0 to infinity. Therefore it is 0.6915. So this is the probability of x takes the values greater than 40. So the between areas we will see in the next class. You try to find out x taking values greater than 35 and greater than and less than 35. So that's it for today's class. In the next class we'll continue with the problems, that is the remaining 3 sub questions, and then we will see general problems of normal distribution.